junior here at Brown, studying biology and international public affairs. I feel honored to be here, welcoming you to this event. SFI was born out of passion for the idea that we could all be kinder to our planet by simply looking at our plate, and that this idea could go miles, being surrounded by curious and caring classmates willing to take action. Our club reached out to Patrick Brown in awe of his work, and we are so grateful he is here, standing before you today, telling you about a story of change that started with a love for science and the planet and a faith in technology. I will pass the floor to Professor Stephen Porter, who will be introducing our speaker. Stephen Porter is the Acacia Professor of Ecology, Evolution, and Organismal Biology and Environment and Society at Brown. He is the founder and science lead on the radio show podcast Possibly, which explores everyday issues related to sustainability and airs on public radio stations around the country. He also serves as the university's first Associate Provost for Sustainability. Please join me in welcoming both Professor Stephen Porter and Patrick Brown.
Thank you, Serena, and to the entire team at Sustainable Food. Amazing job. I'm proud to be the suit that's standing up here saying, giving an introduction, but they've really done just an incredible job pulling this event together, and I'm really grateful, and it's a testament to the fantastic students that we have. I don't usually get nervous when I talk at things like this, but to introduce Patrick Brown is a real honor for me. He's been in my mind since I started graduate school in Stanford a long time ago and was spoken of then as this amazing luminary. I wanted to introduce him by giving you a sense of the breadth of his genius, for lack of a better word, because I think many of you may not know it and know it only from what he's going to talk about today. So Dr. Brown got his bachelor's and MD and his PhD, if I'm correct, from the University of Chicago, and went on to do a pediatric residency, 3 years, and I'm married to a doctor, so I can say 3 grueling years of very little sleep and working in the hospitals saving patients. And then he decided, at least if Wikipedia is correct, that he could do more good doing basic research, which is kind of mind-boggling to me that you could think that after being a pediatrician, since you're doing good. But he's actually someone who has actually potentially, arguably, done more good in basic research than being a pediatrician. He did a postdoc at UCSF with Harold Varmus and Michael Bishop, who did pretty well for themselves and won the Nobel Prize in Medicine, probably because of your work. And went on to start at Stanford and Howard Hughes as an assistant professor. In the 1990s, his lab invented the DNA microarray, and I'm not that kind of biologist exactly, but I don't think it would be an exaggeration to say that invention revolutionized basically all of biology and medicine in really profound ways. That's actually not why I heard of him. I heard of him because in the early 2000s, he got sick of the exclusionary nature of scientific publishing and the enormous cost that journals imposed and therefore limited their access, and started the PLOS series, the Public Library of Science, which was the first open access journals, which are now ubiquitous and very greatly appreciated around the world for their lack of cost barrier to accessing. He then continued to work and went on sabbatical and decided in his sabbatical to do something good for the world. I also recently went on sabbatical. I did not do anything nearly that good for the world. So showing us all up once again. And in 2009, thought that the single biggest contribution he could make personally was to revolutionize our food system. Again, a grandiose idea, but one that he has carried out with incredible, almost impossible, dare I say, success. So he has so many awards that I don't want to stand up here and tell you them, but at the UNEP named Impossible Foods and Dr. Brown as a champion of the earth in 2018. And that's how I think of him also as a champion of humanity for his contributions to all that we know about biology and medicine. It's just a real honor to have you here. Thank you so much for coming.
Well, thank you for that incredibly generous introductions. And I really want to thank Serena and the Sustainable Food Initiative and her colleagues. When she contacted me, I would never say no to a group with that name. So I'm very excited to be here, and I really appreciate everyone coming. So my subject today is going to be the use of animals as a technology for food production, and why eliminating is essential, and how it's likely to be replaced. And I'm going to begin with a look at the catastrophic impact of this technology. I think that I assume the Sustainable Food Initiative doesn't need to hear this from me, but in case anyone does. And then I'll explain why replacing it is not only possible, but I think likely inevitable within the next couple of decades. And I'll walk through a couple of strategies that I've been involved with that are sort of synergistic, that are intended to accomplish the demise of that technology. So, yeah, how I got here, basically, for most of my adult life, I had what I thought was like the best job in the world. And, just so incredibly lucky that I was a professor at Stanford School of Medicine. I had a really busy, fun, eclectic lab with great students and colleagues. It was generously supported by the Howard Hughes Medical Institute. And literally my job responsibility, and I'm not making this up, was to follow my curiosity wherever it might take me. And just try to invent and discover things and be a mentor to great people. So it was absolutely a dream job. And I never could have imagined leaving it. I certainly never could have imagined leaving it to go into the business world. And then 13 years ago, as Stephen mentioned, I took a sabbatical. And basically my intention with this sabbatical was to find the most important and impactful problem that I might be able to contribute to solving. And what I learned very quickly in that process is what led me to quit my dream job and set me in a very different direction. And I'm just going to sort of track what I learned as a way of introducing you to the problem. So I'm sure most of you are already quite aware that our biosphere is in serious trouble. The biodiversity that keeps Earth's ecosystems that we too often take for granted healthy and functioning is collapsing precipitously all over the world. And this graph traces that catastrophic fall in the populations of thousands of vertebrate animal species that were selected about 5 decades ago by a consortium of scientists funded by World Wildlife Fund and London Zoological Society and dozens, if not hundreds, of academic scientists that basically chose a set of species as kind of a representative sample of vertebrate biodiversity on Earth. And then they've been systematically tracking the populations of those species around the world, the number of remaining individuals. And the bottom line from this graph is that today, the global populations of those mammals, birds, reptiles, amphibians, and fish across the gamut are on average less than a third their numbers 50 years ago. I mean, if that doesn't scare you, you're not paying attention. Or you don't think about ecosystems very much. But more recently, there's been a number of studies, like the one shown here, that have reported that insect populations, particularly flying insect populations, are also dropping dramatically around the world to a similar extent. And some have even suggested to an even greater extent than the vertebrate species. The New York Times called this the insect apocalypse, which I kind of like, even though it's kind of inflammatory. But and I think to some small fraction of people, the idea that there's fewer flying insects is sort of good news because it means your windshield will stay clean. But it's terrible news when you consider that 85% of the world's flowering plant species and more than 70% of the world's crops are completely dependent on animals, mostly flying insects, for pollination. It's basically part of their reproductive system. It's also true that 70% of all plant species depend on animals for dispersing their seeds, which is also critical for their reproduction, because you're not going to accomplish much by growing a bunch of trees in the same spot. The same research consortium that was tracking the vertebrate species also tried to allocate the causes of the collapse. It's obviously not something that you can do with great precision, but to the best of their ability. And this sort of represents what they concluded. And I won't go through it in detail, but the gist of it is it's overwhelmingly due to our use of animals as a food technology. Particularly for aquatic species, overexploitation is overwhelmingly the cause. Overfishing, basically, in that case. And for terrestrial species, it's habitat destruction and degradation. And that's almost entirely due to the humongous land footprint of animal agriculture, which is the biggest land footprint of any human activity. And I'll get to that in a second. But we've basically, and this, it's weird that this isn't an exaggeration, but we've almost entirely replaced the diverse wild species in nature with livestock, and mostly cows. And for example, the cows on our planet today, there's 1.7 billion of them, according to UN Food and Agriculture Organization. Their combined weight outweighs every remaining terrestrial vertebrate on Earth, every mammal, bird, reptile, and amphibian that remains, by more than a factor of 15, okay? They massively outweigh every remaining wild animal, okay? And it's not just cows. So livestock across the board that humans use for food together outweigh every remaining terrestrial mammal, bird, reptile, and amphibian by more than 20-fold. And the scale of the world's demand for meat is so huge that, and challenge me on any of this, because I've actually done the math and I can show you the data, but within 2 weeks, if we chose to hunt animals, sometimes when I talk about the problem with animal agriculture, people say, I think we should really go back to hunting for our meat supply. Not a great idea, because if we were to do that, it would take less than 2 weeks to wipe out every remaining wild vertebrate left on Earth. There wouldn't be a squirrel or a chickadee left. Okay, and the land footprint, as I said, is a big part of why it's such a disaster. So when you count sort of pastoralist grazing as well as grazing on permanent established pastures and so forth, animal agriculture as an activity exploits 45% of the ice-free surface of Earth, which, to put in perspective, is greater than the total land area of North America, South America, Europe, and Australia combined. So it's more than 3/4 of the land footprint of humanity. It's to the first approximation, it is the land footprint of humanity. And for comparison, for example, all the crops that we grow for consumption by humans and for fiber occupy less than 7% of Earth's land area. And every city and suburb occupies less than 1.5% of Earth's land area, and every city and suburb and town and highway and parking lot and factory and all human infrastructure occupies less than 3% of Earth's land surface. So a lot of people sometimes think that, the problem that the reason we're, destroying so much of natural ecosystems the encroachment by suburbs and development and blah, 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 blah. And that's because we live in the cities and suburbs, so that kind of looks like that to us. But that's completely wrong. It's animal agriculture, pretty much full stop. Okay, and that clearing of land for animal agriculture historically has obviously been the #1 driver of destruction of forests, savannas, and other natural ecosystems. And that's continuing today. So over the past 300 years, the land area occupied by animal agriculture has increased by a factor of 7, okay, in the past 300 years. And it continues to grow. And more than 90%, you probably know the number better than me. This is from a paper in PNAS 2 years ago. More than 90% of the ongoing destruction of the Amazon is to clear land for the cattle industry. Okay, so you can think of that smoke as the secondhand smoke from your steak, if you eat steak. And I know you guys don't, so. Anyway, then there's climate. So despite all the attention on renewable energy, which I applaud and I get, get excited every time I hear about new progress, the truth is that last year's greenhouse gas emissions set an all-time record, and that will probably happen again this year. So we're making technical progress, but we're not making meaningful actual progress nearly fast enough, and certainly we're not tracking on the trajectory that the commitments that were, not committed to, but I shouldn't say committed, but the goals that were set at Paris, claimed. And in fact, based on our current trajectory and existing policies that have been made, we'll exceed the 1.5 degree, well, it's almost certainly going to happen. We'll exceed that target that was set at Paris before the end of this decade. Very likely surpass 2 degrees Celsius above pre-industrial temperatures before 2050. And if we stay on this trajectory, we'll probably blow through 2.8 degrees above pre-industrial temperatures before the end of the century, which will be the highest average surface temperature on Earth for more than 3 million years. Okay, but those are just numbers and whatever. But so this is a figure. Unfortunately, it's like one of these figures that I always tell people giving talks, don't use something like that because you can't read the text and it's too busy and so forth. But anyway, just trust me on it, sorry. It illustrates the projected risks of some very consequential effects of climate change as a function of temperature. The effects are things like extreme weather events, crop failures, this is a term that I really like, large singular events. So that would be if one of the major glaciers on Earth were to slide into the ocean. Or another one that is getting increasing attention is there's something called the Atlantic Meridional Overturning Current, which is basically a system, like a lot of these systems that are sort of natural systems, you take for granted until something disastrous happens. But it's largely responsible for moderating temperatures on the periphery of the Atlantic Ocean. It's the warm currents going north and the cold currents going south, and that whole system. It's slowing down, and a lot of people think it's entirely due to global heating that it may grind to a halt within a few decades, and that would be very consequential. Okay, anyway, blah, blah, blah. Point is, the risk and severity of the consequences of global heating increase more than linearly with global average temperature. So it's not like things are getting slowly warmer and so forth. It's that the risks of catastrophic events are increasing. And also irreversible consequences. So we need to bend the curve of global heating dramatically, and not just dramatically. I think something that doesn't get said enough. We need to do it fast because we'll cross some, tipping points in the relatively near future, and we'll regret it if we don't do it fast. So, okay. Anyway, there's a lot more I could say about the disastrous consequences of using animals as food technology, but that was enough to get me going on what I'm doing now. And now I'm going to move on to what I consider sort of the good news. And the good news is that it's still fixable. Won't be fixable for very long, but it's still fixable. And I think there's actually quite a simple way to halt and even reverse both global heating and the collapse of ecosystems and biodiversity. And obviously it has to do with what I was just talking about. So this is sort of kind of like not a metaphor, but you could say a microcosm. So this is a trail through a protected California coastal ecosystem, Point Reyes, a peninsula in Northern California. This is my beautiful wife walking on a trail here. And so this is the protected ecosystem. This is basically what a native California coastal ecosystem looks like in Northern California. And over here, you can maybe barely see a barbed wire fence. Okay, and oops. On the other side of that fence is a farm that, no kidding, calls itself a regenerative, organic, grass-fed beef farm, okay? So if you ever see that term and you wonder what it looks like, probably not what you imagined. And the contrast between this biodiverse native ecosystem that holds tons of carbon per acre in the biomass, even though those aren't trees, and this bleak cow-dotted landscape on the left is a microcosm of what is happening due to the spread of animal agriculture globally. Okay. And I wanted to point out an interesting fact that, again, you can do the math here, but the amount of biomass that was lost on that the land footprint of animal agriculture over centuries is the greenhouse gas equivalent of the last 22 years worth of fossil fuel emissions. And of course, the fossil fuel emissions are going up, so the last 22 years worth of fossil fuel emissions is about half of all fossil fuel emissions in history. So the carbon dioxide that was emitted clearing land for animal agriculture is equal to about half of all the CO2 from fossil fuel emissions ever. A lot, in other words. 800 gigatons is sort of the median estimate for that. But the good news is that those emissions and much of the ecosystem destruction is reversible if we stop covering the land with cows and crops to feed livestock. This ecosystem and the plant biomass can still recover on a time scale of a few decades, okay, i.e. fast, and convert those enormous CO2 emissions back into plants and literally turn back the clock on global heating. So a year and a half ago, my longtime collaborator, Mike Eisen, who's a professor at Berkeley, and I published a scientific article that basically quantitatively modeled, it did something that actually hadn't been done before, believe it or not, which was, so people have tried to calculate what are the ongoing contributions of animal agriculture to greenhouse gas emissions and global heating. But what hadn't been done was to model what would happen if we eliminated that industry, which we need to do, and which is what I'm devoting myself to. What would happen if we eliminated that industry? The reason that's relevant is because there's sort of like a greenhouse gas debt from that industry. that we can pay back by eliminating. It's because the greenhouse gas emissions from animal agriculture, unlike fossil fuel emissions, you can't turn CO2 back into coal. You can turn CO2 back into trees. So the greenhouse gas emissions from animal agriculture are almost entirely reversible. And so the big picture on this chart is, okay, this is the trajectory that we're currently on. So this is radiative forcing, but it's basically how much extra heat is being imposed on the planet. And this is the trajectory that we would be on if we could phase out animal agriculture over a period of about 15 years. And the point is, it would very quickly unlock a 30-year period of net zero global greenhouse gas emissions, okay? Very quickly, okay? Put the whole thing on pause, which would be an enormous opportunity to fix things. And through the end of the century, it would offset more than 2/3 of fossil fuel emissions. And the way that happens is, so the green sector is negative emissions, you could say, from biomass recovery on the land footprint of animal agriculture. The purple sector here represents methane. So the thing about methane is when you turn off the spigot, it goes negative immediately. In other words, methane, carbon dioxide has a half-life in the atmosphere of more than 1,000 years. Methane has a half-life of 9 years, okay? The methane that's currently in the atmosphere just from animal agriculture is about equivalent to about 10 years of total anthropogenic greenhouse gas emissions. And the decay of methane, you know, over the first 9 years would pull out 5 years worth of total greenhouse gas emissions effectively. And the same is true of nitrous oxide. So a large majority of nitrous oxide emissions come from animal agriculture. It has a longer half-life that's about 100 years, but it also will decay spontaneously once you pause the emissions. So you're unlocking massive greenhouse gas emissions, and that's how that's accomplished. Okay. I just want to make the point that, and again, I want to say something. I'll say some stuff that are provocative and controversial, and I would like nothing better than for any of you to stand up and argue with me. Okay, seriously, and I would welcome that, and don't be shy. But anyway, okay, so. But I don't think the point is there's nothing else that's been proposed that's comparably fast in achieving that kind of impact on climate change, okay? So this gets no attention, virtually no attention as a climate solution, except for you guys. But it should be number one on the agenda, because we need to do something big and fast. And cheap, and I'll get to that too, okay. Okay, so a lot of people will say, yeah, but what about nutrition and food security? You know, that'll create a huge problem there. First of all, despite relentless propaganda to the contrary from the slaughter cartel, there's abundant scientific evidence, and obviously abundant anecdotal evidence, because you probably know people who don't eat animal products, that no animal products are required for optimal health in men, women, children, or infants any time of life, or for athletic performance for that matter. And not only wouldn't we need to plant more vegetable crops if we phase out animal agriculture, which a lot of very smart people automatically assume, yeah, you'll have to make up for the deficit in animal products by growing more crops. No, we'd have to grow a lot less crops because such a significant fraction of all the crops on Earth exist for the sole purpose of feeding livestock. So in fact, the land area devoted to crops would be much less. And to give you an illustration of that, of just how much we don't need this industry in terms of global nutrient output, this year's soybean crop, which is grown on 0.8% of Earth's land area, contains more than twice as much protein as all the meat produced globally, okay? Just this one crop could replace all the protein from all the meat in the world 2 times over. And the 4 major staple crops in the world produce more than double the calories and protein, again, required to feed the world. So, okay. So we don't need it, that's the point. But finding a way to phase it out, when I finished the sabbatical, I didn't know how to do it, but I realized it was the most urgent problem waiting to be solved. And so how do you approach solving it? Well, one thing that's obvious is that demand for meat and fish and dairy foods is really deeply rooted, and it's a huge obstacle. Nobody needs to eat animal products to live a healthy life, okay? That's completely clear. But the demand for the animal products is not driven by necessity, it's driven by pleasure. And for billions of people around the world, although they don't need to, eating meat, fish, and dairy products is a very important to them source of pleasure in their daily lives, okay? And asking people to give that up is unrealistic. So we're not going to solve the problem by trying to convince people to do something that they've done all their lives and that they love. And any government that tries to mess with people's dietary choices or impose their will on farmers is going to be out the next day. So that rules out persuasion and any kind of coercive regulation. So what does that leave? It leaves innovation and competition, basically, as the tools. Okay, so the way to look at it is the problem is not that people love meat. It's that we're producing it the wrong way. And we're producing it using a massively underperforming, by any measure, including economic efficiency and so forth, a massively underperforming, incredibly destructive, prehistoric technology that hasn't fundamentally changed in millennia. So what other technology on Earth could you say that about? They've all mostly been replaced by now, all of them probably. For thousands of years, animals were the core technology for not only food, but for many aspects of human life and culture. Power transportation, for example, depended on land transportation, depended on animals. And from 600 BC until after World War I, a backpack full of carrier pigeons was the state of the art in mobile communications. I'm not kidding. But the horse and the carrier pigeon have been rendered obsolete by better technologies, by technologies that do the things that we depend on them for way better. And now I think it's the cow's turn. I think it's actually, because it's so massively inefficient and all the other baggage, it's a sitting duck for better technology. It's a crappy technology. So we just need to figure out a way to make the world's most delicious, nutritious, and affordable meat, i.e. make meat that can compete successfully, as these other new technologies did, in the marketplace for those consumers that are supporting the incumbent industry. And then the market will take care of the rest. And this has been done many times before. It's been a recurring theme in the food system since prehistoric times. The whole history of human food, you can think of it as a collaboration between science and nature. Since prehistoric times, humans, and ongoing since then, humans have basically been exploring the natural world and for potential food sources and testing, although they've slowed down tremendously, unfortunately, and testing and experimenting to discover what parts of a plant, what plants and what animals and what parts of those plants or animals or fungi are edible, how to domesticate them, how to cultivate them, how to process them to make them safe and healthy. This is just an illustration of just a really kind of like thing that very cool about the history of food. It shows indigenous Amazonians preparing cassava, which is today one of the world's major sources of calories and has been for thousands of years. And in its natural state, cassava contains lethal levels of cyanide, okay? Enough basically that the amount that you would eat to meet your calorie needs could kill you. But somehow, someone, thousands of years ago, I would not wanted to have been one of the subjects in this experiment, but they figured out that if you grind it into small pieces and rinse it extensively, it becomes not only safe to eat, but very palatable and a versatile ingredient. So I still marvel at that, but it's not the first example of foods that in their native state are toxic and bitter, inedible, that people have figured out how to make core parts of the food system. So as the world changes, basically humans have always improvised and adapted and invented to improve the food system. So, okay, we needed to figure out a whole new way to make foods that deliver all the deliciousness of meat affordably with equal or better nutrition. And that's a very hard scientific problem, okay? The hard part is really the deliciousness. I mean, nutrition and affordability are easy. You don't need to invent anything new to have much more nutritious and affordable diet than you get with these animal products. Deliciousness is a hard one. But I was sure it was solvable. I mean, it's not the hardest, not even close to the hardest scientific problem that scientists have solved even in recent times. So when I quit my dream job, basically to build a company to take on the task of replacing animals in the food system, the first thing I needed to do was to put together the most talented and innovative team of scientists that have ever worked on food. And I say that absolutely sincerely. There's no doubt that this is that group. This happens to be, they don't usually look this silly. This happens to be Halloween, but they do always look that fun because they're such a cool group. Anyway, to take on the challenge of making the best meat in the world directly from plants. So the idea was we'd start by studying meat the way I previously would have studied a disease or some fundamental biological process, basically trying to understand in molecular terms how it works, how meat creates deliciousness. And then we needed to figure out, okay, once we had enough of an understanding, how do we find the right sustainable, nutritious ingredients that we can use to recreate that deliciousness from plants, and then actually figure out not only to make a good version of it, but to figure out a way to make it better than the animal version, because we have to outcompete the animal version in the market. And that depends on it being more delicious, healthier, and more affordable. If we can't pull that off, we're not going to succeed. Okay, so that was the task. So this is just one example of the sorts of things that we needed to figure out and that we learned. So we obviously needed to figure out why meat tastes like meat and unlike anything from the plant world. And amazingly, and this is just, it says something about how people have this blind spot when it comes to food. They sort of take it for granted and don't consider it something that is worth studying, understanding scientifically, or even creatively, really. But nobody knew what it was that makes meat delicious. But there's something special about meat that is pretty obvious when you look at how it behaves as a food. when you cook broccoli, basically it gets warmer and mushier, okay? When you cook meat, something kind of magical happens, which is that you get an explosion of flavor and aroma. Flavors and aromas that did not exist in the meat at all before you cook it. And you get a complete transformation of the flavor profile, as well as a rather dramatic transformation of the texture. So to a biochemist, that behavior is the signal that a catalyst is involved. And I'm allegedly a biochemist, and so there was a prime suspect. And frankly, I would say, if you even just pose the question to someone who has, understands some biochemistry, what do you think it is that accounts for this behavior of meat and that makes it so kind of in another space from all plants in terms of its flavor profile? I suspect that a non-trivial fraction of them would right away say, oh, I bet it's heme, okay? Which to me proves that nobody was even asking the question, because it was relatively easy to answer. But anyway, it is heme. It's a molecule called heme. And this is the molecule that may be familiar to many of you as the molecule that carries oxygen in your blood from your lungs to all your tissues. It's what makes your blood red. And it's also what gives meat its red color. Besides all that, it's one of the best catalysts known in nature. So in your body, there are hundreds of enzymes, proteins that catalyze chemical reactions, whose business end, the catalytic component, is heme. Hundreds of different enzymes, including the ones that, for example, metabolize caffeine or metabolize most of the drugs that your liver metabolizes, including the enzymes that synthesize steroid hormones like estrogen, testosterone, progesterone, cortisol, stuff like that. Those are heme enzymes, okay? It's a great catalyst. Okay, so anyway, that's so here's basically how it works. So imagine you're cooking vegetable broth. So basically, vegetable broth really is a solution of very simple nutrients, okay? Amino acids, vitamins, fatty acids, simple sugars, things that are essential components of every living cell on Earth, okay? Not just animal cells. These are ubiquitous cell stuff, okay? But you just cook that broth, what do you get? A bit of savoriness, nothing to write home about. But if you just add heme to that same simple broth, do nothing else, the same small molecules, it catalyzes the same explosion of flavor and aroma that you get when you cook meat. So that very meh-tasting vegetable broth starts tasting like intensely like beef broth, basically. So discovering heme's catalytic role in meat, which we discovered very early on because it was basically like, it was, I hate to say this because it sounds dismissive, but it's kind of obvious. Meant that we wouldn't need any of the fake meat flavors. We wouldn't need to pump meat fake flavors into the products because we knew how to create them from these simple nutrients, in exactly the way meat does it. So then we need a lot more of it. So our science, I'm not going to go into a lot of the details of the science because it would take up the whole hour. People can ask me about it if they want. But we need to figure out how to make tons of it, literal tons of it, okay, and cheaply. And so what they did was so yeast have the complete biosynthetic system for making heme. They depend on heme too, just like every cell on Earth does, actually. But what they did was they basically, turbocharged the yeast heme production by genetic engineering. And that enabled us to produce, very large quantities of heme by fermentation. And then there's a lot more than heme that's required. And again, it's very interesting in terms of the protein biophysics and stuff like that, but I'm not going to have a chance to get into it. But the mechanisms that create texture and elasticity and the juiciness and the textural transformation of meat are all really, really important. about the process, things that meat consumers notice and care about, okay? And then they had to figure out how to scale the ingredients, how to scale the production process, and how to make the whole thing affordable, okay? So a lot of problems to solve. And, but I'm not going to take you through them, but I'm happy to discuss them at some other time. So, okay, so the premise of our strategy, though, was that none of this matters if we can't outcompete the animal products in the market. And that means that we need to make products that consumers don't just accept, but they prefer. So is that realistically possible? So I'm going to show examples of beef, pork, and chicken made from plants, and these come from Impossible Foods, but this is not an advertisement for Impossible Foods. I just want to, the point I'm trying to make is I'm trying to show you that we have very good evidence that it is entirely possible, and just getting started at this, entirely possible to make the best meat in the world directly from plants without using animals. Okay, so one question is, will mainstream beef consumers be unable to distinguish them from meat from an animal, which is like the Turing test for meat, you could say. And will they actually prefer them? That's really the acid test. Okay, so beef was the first thing that we went after because beef by a huge margin is the most environmentally destructive food product. And I would say fish and shrimp are second, but anyway. So it was the obvious first target. Of course, we're going after all of them, so who cares? But beef first. So this plant-based ground beef that I'm showing here is now available in the US and many other countries. At this point, more than 100,000 restaurants and grocery stores and stuff like that. In a consumer test with mainstream American meat consumers, more than 2/3 of them rated it as good or better than the animal derived ground beef that they've been eating all their lives. There was a paper published by a group at Cornell, I had nothing to do with it, it just kind of surprised me when it came out, where they did a consumer test of 200 consumers and they gave them 4 different burgers. One was just the mainstream beef burger, one was the Impossible Burger, a mushroom plus beef burger. And anyway, they had them rate them for preference. And guess who won? Okay, the plant-based burger. And it wasn't, and quite decisively won over all the others, including the beef burger. Okay, and that was, you can look it up, but that wasn't our work. And it has a significantly better nutritional profile. Same protein, same iron. It's bioavailable iron because it's heme iron, the most bioavailable kind. No cholesterol, lower saturated fat, lower calories, higher fiber. I mean, beef from an animal has almost no dietary fiber, and a much lower environmental impact. And more than 90% of the consumers who have ever purchased it are not vegetarians, not vegans. They're omnivores, mainstream meat consumers, and a majority of the consumers who have ever bought it have become repeat consumers. And also over time, their frequency of repeat goes up. So this is all good news. This is not an ad. I just want to make the point that, this is just early stage, and there's way more stuff to be done and so forth. The point is, it's doable, okay? So pork is not a big deal in the US, but in much of the world, it's the number one. It is the number one most widely consumed meat in the world, soon to be overtaken by chicken. But we did a blind taste test with pork consumers in Hong Kong, where pork is the number one meat by quite a margin, and it was decisively preferred with these 200 consumers over pork from a pig. And from a nutritional perspective, there's no contest because it's got like 1/3 lower calories, 1/3 lower saturated fat, no cholesterol, and blah, blah, blah. So, okay. It's basically same deal with chicken. So there's a chicken product made entirely from plants. In blind taste tests with mainstream meat consumers, a decisive majority preferred the plant-based chicken nuggets over either the best-selling grocery store chicken nuggets or the best-selling food service chicken nuggets. And they have 0 cholesterol, no lower saturated fat, lower sodium, blah, 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 than the animal-based competitors, okay. Again, I really want to emphasize the point. This is not an advertisement for these products. It could be anything. The point is, this can be done, okay? And it will be done, and it will happen, and they're only going to get better and more diverse and so forth, okay? So science is delivered. There's now a technology that in many ways outperforms animals in transforming plants into meat that meat consumers actually prefer over the animal products they've grown up with. But that's just science. Like, why should we trust science when you can ask this guy, Glenn Beck, a very popular right-wing, annoying radio personality.
All right, so now I'm going to try B. B is the fake burger. I agree. B is the real burger. A is the impossible burger. That is insane. That's amazing. That is amazing.
The producer pranked him.
That's wrong to do that. I could go vegan. I could go vegan. You're anti-vegan stuff. Where we both hate vegetables. Yes. And for that, and I'm a rancher.
Okay. I love the part where his head actually explodes, but okay. So, if 200 years ago, if you had asked someone, you know, what the future of transportation would look like, I would bet you that most people would say, well, the horses will be bigger and faster. But then in 1830, the first commercial mechanized land transportation, which was this little locomotive, came along, and it famously ran a race with a horse. Well, the horse won slightly, but the point is, it was never going to happen again, because you step away from this fundamentally unimprovable, the horses never did get faster, by the way, technology. And you now have a technology that you can improve again and again and again in every way that matters to consumers. And that was because you completely sidestep the inherent limitations of this incumbent technology, okay? And the market took care of the rest. So even within about 20 years, you went from a very large majority, more than 90% of households owning a horse, to something like less than 10%, and a very large majority of owning an automobile or a truck and so forth. So the market can work fast. And now it's going to happen again to meat. Trust me. Well, you don't have to trust me, but it will. So I think we're at another technology tipping point. That's what I'm trying to get at. You know, you have a cow. The cow's been doing this for 1 million years, okay? It didn't evolve to make meat. It's not very good at it. It's incredibly inefficient economically in every way that matters. And our scientists have only been turning plants into meat for a little over 10 years. And we're still learning and getting better at it every day. And the cow stopped working on it, I don't know, 10,000 years ago. It's not even trying anymore. But okay, that's fine. Will it happen fast enough? Let's suppose that we believe that this will happen eventually. Will it really happen fast enough? Like, you know, we need it to happen fast. Well, I think if history is any guide, it's quite plausible that it would, because then this is one of many examples I could show. But when the first digital camera was introduced, it was a total piece of crap, okay? It cost $1,000. It could take 8 pictures, and those pictures were 300,000 pixels. Like, that's a microscopic little piece of your, you know, cell phone screen. Film technology just owned the whole thing. 8 years later, Kodak was bankrupt, okay? That's how fast better technology that can be continuously improved can win the game. Okay, but there's a huge question and also a huge potential obstacle to this transition. So the question is, and a very important question, what happens to the hundreds of millions of farmers and ranchers who currently make their living raising animals for food? What happens to them? And they're definitely not the villains. They're just trying to do an incredibly hard and dangerous job to support their families and their communities, the way that in many cases previous generations did. And, we have to think of them, and they're also not just going to step out of the way. Okay, well, one thing to do is let's look at them. And I spent an inordinate amount of time looking at all kinds of weird data. But one of my favorite data sources, actually, seriously, it's like quite an amazing document, is the USDA Census of Agriculture. It's just compulsively detailed and comprehensive. I mean, if you want to know, how many young female mango farmers there are in Rhode Island, I'm sure it's there. Okay. Okay. Anyway, this just came out 2 weeks ago, the latest one. But the same thing was true of the previous one and the one before that. And what was true was more than 70% of beef ranchers and farmers lost money. Okay, they ended the year with net losses, and this has been sustained for many years. This has been true for a long time. And if you took away the government subsidies, their average net income per acre is less than 50 cents. And it's getting worse. Their job is getting harder because it's getting more and more unpredictable, more and more unstable because of climate change. In the EU, it's even worse. It's so bad that the EU governments actually have to pay more than 100% of the income of beef farmers, more than 100%, because they pay their full income, they come for their full income, plus they have to cover their losses because their farms are money-losing operations, okay? This is insane. The most destructive technology on Earth. And the bill is getting picked up by the governments who say they're trying to do something meaningful about climate change and biodiversity. Okay. I'm not trying to piss on the EU, but, well, maybe I am actually. Okay. But anyway, those farmers don't need to be the victims. They don't need to be the victims of global heating, of climate change, or better technology making their work obsolete. And in fact, the interesting thing is the environmental benefits unlocked by the phase out of animals in the food system actually depends on them as critical allies, okay? We need them to be our allies in solving the problem because basically they are the people who have been managing the land that we're now going to depend on for ecosystem restoration and capturing carbon and pulling 22 years worth of fossil fuel emissions out of the atmosphere. So they can be the heroes in reversing global heating and ecosystem collapse and in the process improve their livelihoods. Because I was trying to make the point that these guys are not thriving at all. They're doing an incredibly dangerous, hard job and making very, very little for all their effort. Okay. Just to set the stage about the kind of economic argument here. So economists, there have been several, probably like at least a half dozen studies that have tried to estimate what's the capital investment going to be required to convert the, by 2050, say, the existing fossil fuel powered industries to renewable energy. And the estimates range between $3 and $9 trillion a year, okay? Doing nothing is even more expensive. So again, here's the kind of like weird data that you might think, why would anyone look at this? It's really interesting. This is a Swiss, like a very sober, well, it's almost redundant to say this. No offense to someone was from Strong. Very sober Swiss company, Swiss Re. It's the biggest reinsurance company in the world. Their whole business depends on their ability to quantitatively predict the potential cost of and likelihood of global scale catastrophes, okay? So they published a study maybe a year and a half ago to look at what's the likely impact on the global economy of our current trajectory. So our current trajectory, where we wind up with a 2.6 degrees Celsius above pre-industrial temperatures by 2100, which is, I would say, most climate scientists' best guess of kind of the trajectory we're on, compared to one in which we avoid, going over 2 degrees Celsius above the Paris target, above the pre-industrial temperatures, and stay under the Paris target, ideally. Anyway, the basic point is, in the year 2050, their prediction is the impact on the global economy will be 10% of GDP, okay, which is more than $20 trillion a year that the impact will be. And in many regions, and of course, as usual, it's the poorest countries in the world that get slammed, mostly in sub-Saharan Africa and the Middle East and South Asia. It'll be 30% of GDP. That, by the way, is the definition of a depression, okay? The biggest economic depression in modern history. And this is in 2050, but of course this doesn't just suddenly happen in 2050. This is going to be, we're heading there between now and 2050. I think you could say we're staring on the barrel of the biggest global economic depression in modern history just due to climate change, and it's not going to stop in 2050 either, so massive economic impact, okay. That's if we do nothing. And if we do something, and we should do something, I'm glad we're doing something about renewable energy, that's also, again, probably best median guess is half a trillion dollars a year, okay? On the other hand, the world's cattle farmers and ranchers have a combined gross annual income, not what they get to keep, just the money they make selling their cows into the market, and then they have to subtract all their costs and everything else. Their combined gross annual income is about $500 billion, okay? That's what we would need to provide to compensate, to basically make them even if we phase out their industry. Obviously, we would want to do better than that, both because in general they're economically struggling, but also because we want this to be a strong incentive. So say we doubled their gross income, okay, that would be $1 trillion a year. Again, a tiny fraction of the alternatives we're talking about, okay. Anyway, I think that would be a bargain. I think it's something to seriously try to do. It's not something that any governments are talking about, but I think there might even be a simple market-based way to do this. And that depends on the carbon markets, which we were just talking about. Okay, so feel free to just jump up and tell me, scream bullshit or something, okay? But the carbon markets in the U.S. are very immature. Yeah, actually, a lot of the people who are involved in the carbon markets are very immature too. But and they're chaotic and they're rife with fraud and so forth, and people pretty much know that. They're not completely useless, and they're, I would say, slowly maturing, and there's a lot of effort to make them more functional. Elsewhere in the world, they're doing much better. And I'm not going to get into the details about different kinds of carbon markets and so forth, except to say that, there are places in the world where they're, better regulated, and as a result, the prices are higher, and where there's government incentives to participate in them and so forth, where the prices are on the order of $50 to $100 a ton. Even Canada, for example, just recently made a government commitment, and they can sort of set the prices by policies, to have a price of $170 a ton of CO2 by 2030. Okay, that's just to give you an idea of sort of the range. Okay. Okay, well, this is, when I was doing that study with Mike Eisen on modeling, climate change and so forth, one of the things we were looking at was a lot of data. Obviously, a lot of it had to do with estimating how much biomass how much carbon would be captured if the original ecosystems recovered on land that's currently being used for animal agriculture. And so we can take that information and ask, at a given carbon price, how much would a farmer earn per acre if they switch from cattle to generating and selling carbon offsets? Okay. Even at a carbon price of $50 per ton of CO2, okay, which I think hopefully will be higher than that, but let's just say that, the potential revenue per acre that they could get from carbon offsets over 100 years averages across the US $34 per acre per year, okay? So without government subsidies, they make less than half a buck per acre per year. With government subsidies, even with the government subsidies, they make less than $6 per acre per year. This would be $34 per acre per year for 100 years. And there's more than 100 million acres of cattle grazing land, as you can sort of see from that. This is sort of a color-coded as to how much per acre a farmer could make from carbon offsets, averaged over 100 years. There's more than 100 million acres where they could make more than $100 per acre per year. Okay. So even in today's kinds of shaky carbon markets, there's a very plausible case that the cattle ranchers and farmers could almost immediately be making substantially more income and also bringing more income into their communities than they're doing it now by raising cattle. But there's almost no awareness of this opportunity. I've talked to tons, believe it or not, of cattle ranchers and farmers, and they're not bad guys. And one thing they're quite frank about how much of a struggle it is, and none of them know that there's even a remote chance that they could ever be participating in the carbon market so that it's any kind of a meaningful alternative. So that awareness needs to be raised. So, okay. And the public doesn't know about it, and even policymakers don't know about it. Even the most climate-informed policymakers are completely unaware, I would say, of this being a realistic, economically and climate-wise, a realistic potential. And they certainly don't know about the impact on biodiversity. They don't generally think about biodiversity. So this is the latest project I've been doing. This is also a collaboration with my good buddy Mike Eisen, Berkeley professor, fellow subversive. And I call it the Carbon Ranch Project. It's kind of a cheesy name, but sorry about that. It's a demonstration project, and it's intended to be like a live, real-time demonstration of the environmental and economic good that can come from stopping cattle ranching on an area of land and restoring the native ecosystem. It's also an experiment because we don't know the best way to do this, okay? So the idea is to start with an existing cattle ranch. Step one, lose the cows. That accomplishes more than half the job just right there. And then try several plausible alternative approaches to managing the land and systematically monitor how much it costs to do it, how much carbon you're capturing over time, what revenue it could generate for the farmers, many metrics of ecosystem health and biodiversity, numbers, species of plants, animals, microbial populations, the ecosystem dynamics, etc. And we also need to build a system. One of the things I want to talk to you about. Okay, build a system, a pipeline, a playbook that they can use for monetizing the carbon that they capture. Because otherwise, you could just tell them, hey, this is theoretically, you could theoretically do this and nothing's going to happen. So you need to have tangible evidence and a playbook. And that's probably the most important product is a playbook for the farmers and ranchers that shows them compellingly that this could work and also how to do it and how to make a living from it. Okay. And then let them decide what's best for them, because obviously this is strictly up to them. Okay, this project got underway 18 months ago with funding from the nonprofit Impossible Foundation, which got funding from Impossible Foods. And we used it to buy a roughly 1,000-acre ranch. It's near the Texas-Arkansas border in the little town of Emmett, population 411. It was almost entirely pasture land, as you can sort of see from this drone photograph. About 90% of it was just cleared pasture land, and it had cows on it at the time. It was an active cattle ranch. There were about 550 cows on it when we bought it. But we know historically that it was a dense mixed hardwood forest. We have tons of evidence for that, including the fact that there's a page in the original survey of the Louisiana Purchase that specifically describes this land and what was on it and so forth. So we know it has an innate potential to grow forest. And we can calculate that it should be able to capture about 260 metric tons per acre over the course of about 50 years. That's roughly the timeline over which we can estimate. And that means that rather than making virtually no money or actually losing money by raising cattle, if we were to assume a carbon price of, at the EU rate of $100, say it would be making $260 per acre per year. So contrast that with what they're making today. And that's way more than an order of magnitude more than even a successful cattle ranch makes, which there aren't many of. Okay, so last summer there were cows on the ranch. You can see the little cows here munching the grass. By the way, I don't hate cows at all. I love cows. I just don't love 1.7 billion of them. Okay, the farmer who sold us the ranch took them with him to Louisiana. And since then, we've been collecting baseline data. So we've measured soil carbon systematically over the area. Oh, we also have a partnership with an existing cattle ranch that doesn't plan to get out of the business that's letting us monitor carbon on their property as sort of a control. It's like 5 miles away, very good match. Measured soil carbon. We've used high-resolution LiDAR with a drone to quantitatively measure above-ground biomass, which gives us sort of a three-dimensional image of the biomass on the land, which is very good for estimating that. And just incidentally, it's a very scalable and inexpensive verification technology. You can calculate how much it costs per acre if we were to do this annually. And it's just like a rounding error of the economics, just incidentally. Anyway, the image on the right is a false color image where the color represents height there. Okay. So in the baseline year, we identified more than 150 plant species, more than 115 vertebrate animal species. You can see them doing their thing in these camera trap photos. The site is about 90% pasture land. As you might expect, these animals spend almost 100% of their time in the 10% of the land that is still sort of semi-intact habitat and provides cover and places for them to sleep and so forth. And that's great because we sort of have the seeds already there as the ecosystem recovers to repopulate it. We've set up camera traps, we set up audio recorder arrays that not only enable us to identify the bird species that are there, but also identify where they are in three-dimensional space by just using arrays of microphones. And we're collecting environmental samples for DNA sequencing, which will give her an even deeper look at what's living there, and also by doing something that I find strangely interesting, which is collecting poop samples. I mean, anytime I'm walking around the pot, I get excited when I see a turd, believe it or not. It's kind of sad, but that tells us what they're eating, which is also really important. And then we're going to track this longitudinally as a way, because we don't want to just bullshit you and say, oh, this is going to be good for biodiversity. We have to actually do the experiment and see, okay, what's good. So the way we're doing this, we divide the land. Don't worry, I'm like 2 minutes away from being done. I distract myself and I get too long-winded here, but conceptually divide land into 3 equal partitions that are not completely contiguous because we're trying to sample kind of the different soil types and moisture and blah, blah, blah in the land. They're about 300 acres each, and each of them we've applied one of 3 different approaches to restoration. And they were chosen basically because there are things that a farmer would reasonably consider doing. So one of them is do nothing. This is like just buy a rocking chair and let things recover. The second is to plant a fast-growing timber species, and this is southwest Arkansas, where loblolly pine is the timber species, very fast-growing pine tree. So that was one of the third. The third thing is to plant a mixed forest. We have 28 different species, mixed hardwood and pine forest, and that's the third thing. And then we planted them at different planting densities and also with different types of pre-treatments of the soil and so forth I won't go into. So we covered a lot of parameters and so forth, so we could have something meaningful to, hopefully at the end of the experiment, like, okay, if you care about how much money you make in the first 5 years, this is the best way to do it. If you care about how much money you make in 100 years, this is the best way to do it. If you care about biodiversity, this is the best way to do it. Blah, 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 blah. Okay. Okay, then last month, a crack crew of tree planters showed up on the site, and within 5 days had planted 330,000 trees. And you can see how fast they move. So, quite amazing, actually. No, actually, this is what the process actually looks like. But it's still incredibly impressive. I tried doing this, and I was like 10 times slower than these guys who are good at it. Yep, they just march along, dig a hole, plunk in a tree, next. Anyway, since the best approach to restoring a thriving ecosystem on a cattle ranch is likely to vary considerably depending on, obviously, it's going to depend on geography. It's not going to be the same in a semi-arid area as it is in a relatively moist area like the southeast U.S. It's not going to be the same in a tropical rainforest area or whatever, in the far north, et cetera, all of which have cattle farms on them. We have to do this many other times, okay? And that's what we're doing. We have 2 more sites we've already identified with very different climate and native ecosystems where we're hoping to start later this year. We're scouting for other sites. And okay, so I realize to a lot of academics, this isn't just like an insight, I know because I hear it from them, that this seems absolutely nuts, okay? And we're not even going to begin to have meaningful results in terms of knowing how to approach this problem, probably for at least 5 years, at which point I'll be pushing 75 years old. I mean, I'm already a geezer, but I'll be even more of a geezer. And, but the way I think about it is like the sooner we start, the better, okay? Like the fact that we're not going to get answers right away is not a reason not to do it. It's a reason why we better get our asses in gear. And I can't think of anything more important to do with my time. And, hope I'm right, but stay tuned. And thank you all for listening and coming here.
Thank you so much. We have a couple of microphones set up, and I think we have time for a few questions. So if you'd like to ask a question, please line up with the mic, and that way people will hear it on the recording. And maybe I'll start a question. Marcello, you are first. Take it away.
I don't know. I don't think it's on. I can just talk. Thank you so much for coming. It's amazing to hear you speak and meet you. I've been encountering recently biotechnology companies that are making low-carbon animal feed either out of seaweed or insects, and I'm wondering, do you view this kind of effort as a potential moral hazard and something that could delay the sustainable food transition?
Well, first of all, anyone who's trying to make a positive impact, I appreciate, okay? So, you know, that's not what I would do. I don't think it's the right solution. I do have a lot of issues about it. It's certainly not even close to what you could accomplish by getting animals completely out. You know, insects are more efficient than cows, but they're like, you know, 3-to-1 protein efficiency. Why not go for 1-to-1? But yeah, so no, I think that's, I mean, I'm glad people are working on all kinds of different solutions. I'm not claiming like I'm the only one who has the answer, so the more people are working on it, the better, as far as I'm concerned. I hope that's not where it ends up, but we'll see.
Thank you, Dr. Brown, for giving us so much hope. My question is about the last 10 years. What's the biggest thing that surprised you about the success or the barriers you encountered with Impossible, and how does that relate to how you see our widespread adoption of non-animal technologies for food?
So what were the biggest barriers to success and adoption and so forth? I would say the science was never a barrier. It's, you know, we're learning all the time. I mean, this is such an early stage. So it's not the science, not the technology. One of the problems is that when you're scaling a manufacturing process, or you're scaling a process that makes physical things, growing is capital intensive. Like if you're making something that's made out of data, you know, or bits, it's like there's virtually no capital cost to scaling. This is capital intensive. And especially if you're scaling fast, the way you think about it is, if I have to spend, you know, $100 million building a plant and it's not going to be producing anything for 2 years, and let's say you're growing at a rate where you have to do that like year after year after year, you're investing tons of money and with a delayed return. And I can tell you this, an obstacle is, okay, this was actually a surprise to me in a way. People who are in the finance industry, it's all about money to them, okay? And I really was surprised by that. I mean, I was just like, are you kidding me? This actually exists? Yeah, it's all about money to them. So when the economy is shaky, they're very reticent about making investments that are not going to pay off relatively quickly. So that's just sort of an inherent problem when you're in a business that requires capital investment to grow. Another problem that's not like a barrier, but it's you know, something you have to contend with is that the supply chain of ingredients that are suitable for making plant-based foods is extremely thin. It was never a thing before, really. And you know, when we started working on it, one of our considerations is this has to be scalable, and it has to be cheaper, you know, at scale than the animal products and so forth. So that limits some things. One of the ingredients, a number of the ingredients we looked at that were better than any of the ingredients we're using right now, and you know, were awesome in a lot of ways. We had to, you know, set aside for now at least, because there was no way we could create the supply chain fast enough to get things going. And when you're dealing with the agriculture industry, it's incredibly conservative, okay? Incredibly conservative. You know, the big ag companies and stuff like that. So the likelihood that, well, I've done the experiment, so that, you know, me going up to them and saying, hey, if you make this, you know, new crop and scale it and stuff like that, you know, I'll be your customer, will persuade them to do anything is approximately zero. So, but that, all of this is, I just feel like the semi-obvious things that if you're a startup that's, you know, trying to grow fast and make stuff, just part of the game. So I don't, you know, it's a totally manageable problem, but you were asking like they're not obstacles, they're hurdles.